Everyone, welcome to Cassandra Lunch. We'll give everyone a couple more minutes to file in, and we'll go ahead and get started soon. Everyone, welcome to Cassandra Lunch. We'll give everyone. Everyone, welcome to Cassandra Lunch. We'll give everyone another minute or two to file in, and we'll go ahead and get started soon. Alrighty, go ahead and cut the music. Hey everyone, welcome to Cassandra Lunch number 96, 1 month away from the big 100. If anyone has any topic suggestions we should do for the big 100, feel free to drop a comment on the YouTube video and we'll see if we can make do with it. Today's topic is going to be on Cassandra CDC or change data capture strategies. Today's talk is going to be given by Rahul, who's the CEO at Anant, as well as architect. Rahul and myself are the co-organizers for this event. We are looking for guest speakers for Cassandra Lunch, as well as our sister lunch, Data Engineers Lunch, as well as spreading the word. If you're watching this on YouTube, it's easy enough to share it to a friend. Don't forget to like and subscribe. That helps us get into the eyes and explore pages of more people as well. And if you're looking to sponsor Cassandra Lunch or Data Engineers Lunch, don't forget to reach out to me. My email is listed below. Data Community DC, we are a part of Data Community DC, and Data Community DC believes in building a diverse and inclusive organization. So no matter your race, gender, or sexual orientation, everyone is welcome, and we expect the respect to be given to all. Data Community DC is built up a bunch of different organizations. Our sister lunch, Data Wranglers DC, falls under, or Data Engineers Lunch falls under Data Wranglers DC. So if you're interested in all the various events put on by Data Community DC, you can find out more at datacommunitydc.org. So what do we cover here at Cassandra? We cover everything that is, talks, or plays well with Cassandra. So whether that range from open source Cassandra or an enterprise like DataStax, Skilla, Yugabyte, Amazon Key Spaces, as well as managed open source like Avon, Instacluster. And we also talk things that play well in the ecosystem, such as Kafka, Spark, Airflow, etc. So there's a variety of topics we talk about. If you're interested in anything, if you want to give a talk on something that you've worked with in the Cassandra realm, feel free to drop a comment or reach out to me via email if you want to give a talk at Cassandra Lunch, or as well as Data Engineers Lunch. If anyone's new, say hi, hello in the YouTube chat or Zoom chat. Group rules, if you have a question, please do ask it. This is meant to be a community, so the more you want to learn or more you want to teach others, the more beneficial it is for everyone. But please be polite and courteous to others. Again, as mentioned, this is a community, so please do share what you know with us. The guest speaker may have preferences in terms of when they prefer questions, and then they'll cover those preferences when they take over. Here at Anant, we design, build, and manage global real-time data analytics platforms surrounding Cassandra, Spark, and Kafka. So Cassandra is our bread and butter. DataStax is a partner and a sponsor. GW University helps provide venue space when we have in-person events. We also have some institutional organizational sponsors. If anyone has any announcements, if they're looking for a job or offering jobs, feel free to drop links in the YouTube comments or the live chat or the Zoom comments, and we'll get them transferred to and from. Or if they have any meetups, hackathons, or conferences that they would like to promote, feel free to drop links and we'll get them shared around. DataStax Astra currently has a build-a-thon that's ongoing. I believe the second month is wrapping up. So if you missed the first or second month, you can always catch up on in the third month. So each month will have a round of challenges. And then the top 3 winners of each round qualify to present their project ideas on demo day. So even if you missed the first or second, you can still qualify for demo day if you end up being one of the top 3 winners of the third round. And there's cash and swag prizes to be won at each round, as well as demo day, so feel free to join. Anant is hiring for full-time and part-time positions, data platform operator, engineers, architects. You can find out more at careers.anant.us. We have upcoming events. We have our data engineers lunches, which happen on Monday at 12 Eastern. Again, we are looking at a more variable time slot to cater to a live audience around the world for Data Engineers Lunch as well as Cassandra Lunch. So be on the lookout for announcements for that. But currently, we'll keep on chugging along with the 12 p.m. Eastern time slot. So if you do end up missing the live event, don't forget to subscribe to our YouTube channel. These events are live streamed directly to YouTube, so the playbacks are available immediately once this event ends, as well as ongoing. And all of these videos can be found on our Cassandra Lunch playlist. If you just Google for Cassandra Lunch, you'll be able to find it. We started recording around Cassandra Lunch number 10. So from number 10 to today, 96, all of them are available on the Cassandra Lunch playlist. And Cassandra.Link should be your number one resource for all things Cassandra. You can find these resources anything that's pertaining to Cassandra as well as the ecosystem. So you see we have our tags, Cassandra, Spark, Kafka. These are resources in the realm of Spark and Cassandra, not just Spark in itself. So any questions or videos or news you want to find out about Cassandra, check out Cassandra.Link. And all of these resources are hand curated by the team here at Anant. And with that, we will go ahead and pass it over to our speaker for today, Rahul.
Hey, good morning, good afternoon, good evening. Thanks, Arpan, for starting us off. I just wanted to make a note of something. Yeah, we're coming up on 100 episodes here. We may need to break up our Cassandra lunches into seasons. Yeah, it's a good day. Thursday, I think, is a good day. We may want to update. I think you just did that. Thanks, Arpan. Thursday seems like a good day for having these lunches. Today's topic is about change data capture, and CDC is a term that most people will see in the data world. Some people like, what does CDC mean? Is it the Center of Disease Control, because the CDC is all over the news related to pandemic? I'm like, no, CDC is change data capture. It's always been both, but in the data world, it's change data capture. I'm going to share my screen and let me know if there is any problem. Okay. Is that visible?
Yep.
Okay, great. The purpose of today's session is to give you, the audience, an understanding of change data capture as it relates to Cassandra, Apache Cassandra, and actually you can use a lot of this with Scylla and other databases, how it relates to Cassandra in terms of getting data in. So change data capture from the outside, from other systems, other databases, and also change data capture from Cassandra into other systems. Change data capture is a big subset of the data engineering community lately, because people don't just run one big database anymore. It used to be you pay for Oracle SQL Server and you had everything in one server. But as data has increased, we have to keep data synchronized between different databases. Of course, when you're using something like Cassandra, you can actually have one big cluster, massive cluster. But every now and then you still need to do CDC. So there are different tools and different technologies for doing it. What we're going to do is we're going to cover the strategies, and then we're going to talk a little bit about the tactics. And what you'll walk out with is an informed or educated understanding of CDC in the Cassandra ecosystem. There are tools and technologies we'll talk about. I'm not endorsing any of these. I'm just going to make an objective recommendation at the very end, based on our company's experience, based on my experience, based on our clients' experience. And there may be other tools and technologies that you are aware of. Feel free to put them in the chat. If you're watching on YouTube or if you're watching on Zoom, and I'll address it. And if you're watching it on YouTube after the fact, I would love to hear what other tools you've used in the Cassandra comments. Sorry, in the YouTube comments. I felt like I had to bring this quote in. This is a quote / joke in the computing industry, that there's only two hard problems in computer science: cache invalidation and naming things. And Martin Fowler has a whole page on it, and Martin Fowler is like a father of software architect, one of the fathers of software architecture, design patterns, and he's written a great book on refactoring. And he actually says that it comes from the guy named Phil Carlton, which I don't know who that is. But then he has tweets on his page about other people citing the same quote. What does this actually mean, and what does this have to do with change data capture? So when we build applications, we're naming things as what it's going to be inside code, and we're also determining what of that inside code is getting displayed to the user. but at any given point, the user is seeing something in the past, right? So if there's a database, right? By the time you are looking at a page that is powered by a database, if there's not an immediate, like real-time update anytime a database is updated, then you're basically looking at the past. You're looking at the data as it was the moment it was retrieved from the database. So what you're looking at on a web page is actually a cache of what is in the database. And that is how I understand it, right? Why is that a difficult problem? Well, you have to name your databases properly, you have to name your tables properly, but then this cache and validation problem is like, well, the user needs current information. So how quickly can we refresh that information? So in the past, we made websites and web applications, you would have to refresh and it would do a post or a get from the database and it would come back. Later on, people started to add AJAX, asynchronous JavaScript and XML. And now people do that with JavaScript object. So it's asynchronous JavaScript and JSON. Basically having, your front end, your single page application call JavaScript, calls to some REST API, get the data, and then either take it and then update the HTML via React, Angular, or roll your own web page. But at each stage, the data is named properly. It gets massaged from one structure to the other, so it can then eventually make its way to the user. So a database has tables, field names. It gets put through REST API, which has a structure, labels, field names, values. Then it gets brought into the HTML view, where if you named it properly and your code is binding to a structure properly, then it gets shown to you. So at every single stage, the naming is important, and every single stage, the cache is important. But you're by no means looking at data in real time, right? The universe is not built like that. There's a limit to speed, and the speed of light is that limit. So when people talk about immediate consistency, right, ACID, what they're really talking about is things are locked until they're done. And so ACID was not going to scale in the distributed world, right? If there's a million things happening on a table or an object, and it all had to wait until everything was done to have consistency, then it wouldn't work. And that's exactly what happens in the blockchain world, by the way. The whole proof of work of all of the systems coming to consensus, Bitcoin is slow because everybody needs to make sure it's consistent, right? So what does it have to do with this? What does it have to do with change data capture? It has everything to do with change data capture, because there are different databases in an organization's business platform, and people are trying to update other systems with that data. So if you have a SQL Server database, a MySQL database, you have a Cassandra database, and let's say you want to build a analytics dashboard that aggregates everything and massages it to show some description of what's happening or some prediction or whatever, right? You could do batch, which we've talked about in Data Engineers Lunch. You could do batch. You can say, get everything from this database, dump it to S3, and then take it and then import it into Cassandra or import it into Snowflake or Redshift or whatever data lake or data warehouse technology you decide. And then you run the query and then you'll get it, right? But that's not real time. Your cache is only as relevant or as current as how long your batch took, right? So when you want real-time analytics in a real-time business platform with many systems creating changes, then change data capture is a mechanism for us to keep things eventually consistent across the enterprise. Now, Cassandra, if you're aware, is already eventually consistent. You can do that with data centers, with nodes. We're not going to talk about Cassandra today because, well, we are talking about Cassandra. We're not going to talk about how Cassandra achieves that consistency. What we're going to talk about today is how to make Cassandra be consistent with other systems, whether we're making Cassandra updated with data coming from the outside, from other databases, or we're making other databases more current from what's happening in Cassandra. So any questions before we start diving in? Did that make sense? I know there was a little bit of a tirade around naming things in caching, cache invalidation. But do you guys understand how this quote relates to what we're going to talk about today? All right, I'm guessing yes, because there were no comments or questions. Cool. We can do change data capture with batch, right? So we can do batch N using copy, DS bulk, Spark, a bunch of stuff. If you Googled Cassandra data operations guide, you'll find our blog post with like 6 different ways to do it. Batch in, batch out. Yeah. That's not really change data capture in the sense that it's not capturing the changes. It's just taking everything, right? But you could tweak your export query and your from whatever system and your import query to say only get the data that was created after this date, if that's a column that you could query on. Or when you're inserting, only insert the things that are after a particular date, right? So you can do change data capture by basically filtering by date, okay? And if you do it, let's say once every hour, you're okay, right? Your data is current to the hour. But what happens if you have tons and tons of changes happening and you just can't wait 1 hour, 2 hours, 3 hours to reconcile that from getting it out and putting it in? So then we look into change data capture in and out using the CDC log, the change data capture log. Most databases, mature databases, they're built on a log. The log is what has happened in the system. And then the system materializes those events into the data sets. So in the Cassandra world, we have, if you're aware from previous sessions, or if you know about Cassandra, when data comes into a cluster to be written to the cluster, written to the database, it gets put into memory first, a mem table, and then it gets put into the commit log immediately. So that if the cluster node went down, after it comes back up, it would read the commit log and build back up what it lost. So it goes to the commit log and memory. So when we turn on CDC, what we're really doing is saying, take that commit log and save that somewhere else that I can then pick up. Because the commit log gets flushed every now and then. It gets cleaned out, right? So Cassandra has that mechanism. But there's other databases. MySQL has a bin log. Oracle has a bin log. These are binary logs. SQL, all of them has a T log. In fact, when you take a backup, you do a backup of the T log and the actual database. Okay, that's the mechanism that we're generally thinking about when we're doing CDC. Is we're talking to the source of the change is the transaction log. Now there are other systems that approximate CDC, and we're going to talk briefly about it. Symmetric DS and AWS DMS, which basically they query the same table, or what they do is they have at least Symmetric DS, depending on the database, it creates a trigger. So when the data is updated, it basically writes it somewhere else. So it approximates a CDC. Now, getting data out of Cassandra, right? We have 2 different ways. One is a trigger and one is a log. And those are the tactical ways of doing it. But as you'll see, I'm not going to recommend you go down to that level. I'm going to recommend what makes sense across CDC and CDC out. But it's helpful and informative to know what these things are built on, first of all. Right? We're dealing with the same tools. It's just one is a higher order tool and one is a lower order tool. So it's important to know how the thing is running. And if needed, you have the power tool to be able to do something beyond what these existing packaged solutions have to offer. Any questions? Okay. One of the main ways that we use in the Cassandra world and beyond Cassandra for synchronizing data via change data capture is Kafka Connect. Kafka, as an open source project, is made up of many different subcomponents. One of them is the Kafka broker. Like in this case, this is represented by this picture right here. These are different topics. And then this is represented here as this block. And in this case, it's the Kafka cluster over here, right? And here we are Kafka brokers. One of the other major tools in the Kafka ecosystem is Kafka Connect. And a Kafka Connect, it can either be embedded in your program, or you could have a Kafka Connect cluster. And a Kafka Connect program or cluster essentially runs two types of programs built on lower level technology, Kafka streams, which basically either get data, they fetch data from other systems, or they send data to other systems. And they're called source connectors and sink connectors. They're represented right here. You can, and I by the way, I ganked these pictures from Confluent, Instacluster, Debezium, and all of the links are in the resources at the end of the presentation. So you can read more about what these pictures represent. But as you can see, as people are defining describing this scenario differently, it's all the same thing. There's a Kafka broker where the data is sent to, that's the channel, okay? There's a Kafka Connect ecosystem of sources and sinks. And I think this is more accurate because these connectors that are taking data from the sources are dumping stuff into Kafka, and then these connectors are taking things out of Kafka and putting it into the sink, the destination. All right. This session is not about Kafka Connect, but maybe in one of the data engineering lunches, we'll go deeper into this, or maybe we'll have one special for Cassandra and Kafka. The other major one that has recently surfaced in the Cassandra world is Pulsar. Pulsar, like Kafka, is an ecosystem. There's a Pulsar broker, and then there's Pulsar IO, which is very much like Kafka Connect. It's got a source and a sink system. It's got connectors for different things. And then, DataStax has acquired a company that became Astra Streams, and they support Pulsar. So they have invested time and money into connectors for Pulsar. They also have connectors for Cassandra and DataStax. Symmetric DS is an open source project. By the way, Kafka Connect, Pulsar, Pulsar IO, these are open source projects. There are commercial variants of those, and we'll cover those later. But Symmetric DS is another open source project. It also has a professional commercial tool. But Symmetric DS focuses on relational databases. It doesn't really cover Cassandra. So why would we want to look at Symmetric DS? Because Symmetric DS has connectors to a lot of relational databases, and it has a connector to Kafka. As long as we can put stuff into Kafka, we can basically bring it out of Kafka and put it anywhere we want to, right? So from relational database into Kafka, from Kafka into Cassandra. And since Pulsar has a Kafka compliant API, right, you should be able to use Pulsar as well. There shouldn't be any reason why you couldn't, but I'm not going to certify that. I'm just going to say it's potentially possible. Here's a strategy, right? So you have sources and you have sinks and you have channels. Kafka ecosystem, there are open source connectors, and there are Debezium, which is basically owned by Red Hat. They also have open source stuff. And so Debezium is a company that focuses on change data capture from many, many databases, and they have more commercially supported connectors. So in terms of most systems, you may already find an open source connector, but Debezium has some good ones, right? Pulsar also has, it's open source, it has its own connector ecosystem. Not as many as Kafka Connect, but it has quite a few. Symmetric DS has tons of relational connectors. Sybase, SQL Server, MySQL, Oracle, you name it. And then AWS DMS, which is Data Management Studio, is a tool, or I think it's maybe it's a data management system, is a tool that's unique to AWS, which allows folks to take a database like Amazon RDS or some other system or Oracle and basically create a change data capture from those tables whether or not you have access to the bin log, actually. It does it via queries, and it can land that data into S3, and S3 has a connector to Kinesis. You can put Spark on those events using Databricks. So AWS has some change data capture mechanism that really make more sense in AWS. But let's say you do get the change data from Oracle or MySQL, and you get it out of DMS and you put it into Kinesis or SQS, then you have the ability to use, ACA, or you can roll your own. That's what RYO stands for, roll your own. However, if you use Kafka Connect, okay, or Pulsar, you have to use the Kafka channel for Kafka Connect, and you have to use the Pulsar channel for Pulsar IO. That's a must. However, if you use ACA, Alpaca, or any of these other roll your own, whatever programming system you use, okay, you could technically pull from any of these systems. All right, and the reason I mentioned RabbitMQ, AWS SNS, SQS Kinesis here is that Kafka, Connect, Pulsar IO, ACA have connectivity to all of these. So if you can't do everything in Kafka Connect or everything in Pulsar, you can basically find ways to route data in. And that's a data pipelining conversation, and that's a different conversation. But you should at least understand that there are different ways to get data into Cassandra. The most likely way is you're going to publish data to Kafka or Pulsar using Kafka Connect or Pulsar IO. And you're going to read data from those channels, and you're going to save it into Cassandra using Kafka Connect or Pulsar IO. The main benefit here is that you don't have to necessarily program anything. You're just declaring, get data from this database, put it into this topic, and take data out of this topic and put it into this table. Whereas here, you would have to program everything. It's a lot of work. So you think that if I can just, set this up, configure it to do it, it's going to work magically. It can, but you have to be careful. So Cassandra is still going to be Cassandra. Just because you're getting data out of another database doesn't mean that you shouldn't watch out for the same anti-pattern. So, is the data that's coming from another system, are the keys designed properly? Are those primary keys designed properly? Do they need to be replaced with surrogate keys, or do you need to put a composite partition key when you create the table inside Cassandra? Is the data coming in going to have nulls when the changes are coming in? Because that could cause tombstones. Do we need to maybe format the data as it comes in to be empty strings or just not have it at all? Do the tables need to have referential integrity? If we have multiple tables being updated from outside, is there a possibility that one table is updated before the other table because in a relational database they will be consistent, but when the events come into Kafka, they're going to be coming into in an order, right? They're not going to be all coming at the same time stamp. It's going to be ordered in a particular way. So do we need to worry about that? And then finally, do we need to do any type of transformation of the data, an in-flight or after-flight transformation? So when we get data into Cassandra, we can do a simple sync, which is you don't do anything with the data, right? So these scenarios right here. But let's say you do need to do something before you put it into Cassandra. Well, if you have something called a single message transform in Kafka, it can take data from a particular topic or the connector itself. It can transform it right before it goes into the topic. And the same way the connector could pick it up from the topic, and you can do a single message transformation. And we've done this with Elasticsearch. We had to do something special with it. It is what it is. It can only change the message that it's looking at. In Kafka Connect, without using an SMT, what you could do is you could put data from the source into a topic, have a Kafka streams process running on that topic, and then another connector could be taking it from that and putting it into the sync. It's a different way of doing it. And in Kafka streams, you can do lookups from other topics. You can do lookups from other databases. It's pretty cool that it's basically happening in real time while you're synchronizing data. And then Pulsar streams and Pulsar IO, again, has a similar relationship. But if you need to do highly complex transformation, that's where Kafka streams, Kafka Connect SMT, that's not going to work for you. Kafka streams will work for you. Spark streaming will work for you. Flink is a streaming platform similar to Spark streaming, different parent, but basically it's another thing that you could use. And then Alpaca is basically an ecosystem of connectors around Akka streams. And the cool thing about Alpaca Akka is that it has back channel management. So if you're not able to write data as fast, okay, into where you're sending it, let's say Cassandra, it can basically slow down the messages and keep it in memory before it pushes it through, or it can even tell the system that the data is coming from to say, hey, hold up a little bit. Any questions about getting data into Cassandra? Okay. Change data capture outside of Cassandra, getting it out of Cassandra, rather. So the sources that we can use from Cassandra, we are limited. You can either use the Debezium connector, because the open source community doesn't have one. Okay. And I think DataStax has one too. I should mention that there. Pulsar IO, there is a connector. In fact, it recently got released for Cassandra. And those are the ones that would work with Pulsar IO or Kafka Connect out of the box. And your third option is basically to roll your own. Don't want you to do that, but we'll talk about it. And then when you roll your own, you can do it by either making a trigger that is triggered when there's an update to a table, or you can do it via reading the CDC logs yourself. Technically, these are also reading the CDC logs for you. So we'll talk about how this works, so you know that how it works. But I'm going to recommend don't make your own. It's not worth it. The channels could be the same. So if you're using Kafka and Pulsar Connect, or Pulsar IO and Kafka Connect, those would go through Kafka and Pulsar. That's why they're bolded like this. And then the syncs, there is a Cassandra sync for Kafka. There is a Cassandra sync for Pulsar. Right, just connect it. Or you could take data from whatever channels and use Kafka streams to directly save data to Cassandra using a Cassandra driver. These syncs are basically built on top of Kafka streams and Pulsar streams. So, I mean, unless you really need to do something special, probably not needed. And Akka and Alpaca, they have a way to put data in there. Just because, you know, Akka and Alpaca, these are Java or Scala programs. So what it's doing is it's wrapping the Cassandra driver with its own kind of flow management system. And then for writing data to Cassandra, technically you could pick up, you know, Kafka and Pulsar are not limited to work with Kafka Connect and Pulsar. There's programming languages that talk to all of these, right? So you can roll your own serverless function, traditional compiled code, you know, Spark streaming job, Flink job, whatever, right? You could use that to basically grab messages off of this, and you can write data yourself. Wouldn't make sense if you just want to do change data capture. This would probably be the easiest way to do it. CDC, I'm going to show you a couple of pictures. And I put them in one because they kind of go together. So these three go together. So CDC, if you were to roll your own, you would have to have it running on every node that Cassandra is running on. And it would look at the raw directory and it would send data to a Kafka topic that you would, you would design it. Now, what's happening when you write data, remember we talked about it, It writes to a mem table, it goes to a commit log. That's what happens. Now, when you enable CDC, it copies the commit log and moves it to CDC raw every time you write data. It does it periodically. It's not 100% real time. You can change the frequency at which it happens. Okay. Or you can change the throughput rather, and you can change the frequency at which, how you manage this data, because it's going to fill up, right? Commit logs get cleaned out. But if you don't clean this out, this could be filled up. So when you have a mutation of data, okay, every partition update that's coming into a partition, which could have multiple rows, gets broken up into multiple row updates. And those are the changes that basically come out of a CDC. So if you updated 5 records inside a partition, you would eventually then get 5 update entries. And you could build this yourself. Probably don't want to, because Kafka Connect and Pulsar IO basically do that for you. So here's a breakdown of how Pulsar IO does it. Pulsar IO takes your change data capture, puts it into the Pulsar broker, and then you connect your Pulsar IO sync to basically say, take from this table, right? Take from this topic, put it into this table here. And you could have your source do the same thing. Take from this table, put it into this topic, take from this topic, put it into this table. So that's basically how Kafka Connect also does it. What you can do in both Kafka Connect and Pulsar is, hey, get the data from this one table, run some process on it, so Pulsar IO function or a Kafka Streams function, and then that data gets put into a different topic, all inside either Pulsar IO or Kafka, or Pulsar functions or Kafka Streams. And then Pulsar IO takes from that table and puts it into Cassandra. So in this case, basically, what we've done is we're taking change data from one Cassandra table, processing it, and putting it into another Cassandra table. You could do that with Spark Streaming also. But it just shows you that you could do things between not only outside Cassandra to inside Cassandra, you can also do things inside Cassandra with inside Cassandra. And here's a situation where data is coming from a table in Cassandra, going to a topic inside Pulsar, and some functions are saving it to different topics here, and different sync connectors are going to different destinations. So this topic is going to a data warehouse, this one's going to an analytics stream, this one's going to an operational data store, meaning like another relational database. The other way to get data out of Cassandra is to use a trigger. This is actually showing a prototype that we worked on, I would say like 4 years ago, before the CDC stuff got really good. Triggers were another way of doing it. And what I mean by that is, if you didn't use one of these ecosystems, Pulsar, IO, or Kafka Connect, you were reading your own CDC data, you would have to dedupe the data, because every time the commit log is replicated, meaning like a replication factor of 3, every time a message would come, right? So it took work to do that, to know which one is the right message, so triggers were another way of doing it. Don't recommend using it, but that's another way of doing it. You can write a trigger in JavaScript or Java basically to attach to a table. And when it runs, you can do anything with it. It's a programming language. So JavaScript or Java, you can say, send this data to Kafka. And Kafka Connect could then take that data from Kafka Streams and then save it to whatever you want. So in this case, we were saving it to Solar, but you could connect to anything you wanted. So some considerations, right? Triggers can be configured per table. It's basically sent right before each insert, update, or delete, right? And passes it to the JVM or the JavaScript object. Now, triggers are called only once for each row. So if you have a failure, you have to handle that. Okay. And it does create a little bit of an overhead, right? Because it's doing it inside memory, inside Cassandra. Considerations for CDC. So again, it can be turned on any table as long as you have CDC enabled in the whole cluster. And the big thing is that you need to manage those raw logs that are getting copied over. Otherwise, if that disk fills up, CDC is no longer going to move data from the commit log to the CDC raw folder. And the CDC log itself has a ton of information coming in around key spaces. So it has to be filtered, right? So doing your own commit log, a CDC reader, you have to do a lot of work, right? Including, as I mentioned earlier, you have to dedupe the messages if it's, roll your own. So just use a tool, use Kafka Connect, use Pulsar IO. It does it for you. Key takeaways, Netflix, Yelp, etc. They've had this problem because they use different databases, including Cassandra. They've written articles on it. I have some articles in the resources section. They've tried different things, spent millions of dollars. And then over time, Confluent, Debezium, Pulsar folks started to standardize it. Now we have Kafka Connect and Pulsar IO ecosystems. There are some managed services for Kafka and Pulsar brokers, meaning just the place where you move information. But not as many Kafka Connect managed systems. So like if you use managed Kafka service on Amazon, you're not getting Kafka Connect. You still have to run that yourself. Right? Astra, DataStax Astra, they have something called Astra Streams. It basically has a way to do this for you. If you use Astra, however, not necessarily Cassandra, right? So it's kind of managed Cassandra plus managed Pulsar IO to get data out. Now, everything I mentioned is free, but free is never free, right? So you got to think about where you're investing your time. Confluent, Debezium, Symmetric DS, Strim is another one that I didn't mention. It can save a lot of time, right? And there's a lot of tools in the data engineering ecosystems and not as many in the Cassandra ecosystem, but that doesn't mean that, you have to go use open source or you have to go buy something. You have to really decide if it's worth it. So if you can do this on your own and do a pretty good job and it's working fine for you, go for it. But if you can't, I would recommend just go buy the tool. Most people can get by with Symmetric DS for getting data outside of different systems into Kafka and using Kafka Connect to do pretty much everything else, or Pulsar IO to do everything else. Other folks need something like Debezium, which is built on top of Kafka, by the way. Debezium is a set of things built on top of Kafka, and it can do everything for them. So main takeaways, don't reinvent the wheel. It's like our internal mantra at our company, at Anant. Use Kafka Connect or Pulsar IO out of the box, open source if you can. And then if you need to, pay for it if you can. Bunch of resources that I mentioned are here. They will be uploaded to the blog at some point. And that's it. Any questions from the audience? Everybody's
actually,
yeah, go ahead.
I missed the chance to ask it earlier about the difference between the light transformations and the heavy transformations.
Sure.
Was it about number of steps? Was it about necessity of pulling in other data?
Yeah, let me share that again. Are you able to see my screen?
Yeah.
Is it full screen for you, or does it show a browser?
It's full screen.
Okay, good. So simple sync is we're not doing any transformation, right? Just taking data from one system and putting it in another. Zero transformation. Medium complexity means that essentially, in each of these things, I'll talk through it. So Kafka Connect SMT basically operates on every message. It doesn't do multi-message. Some of the times when data is coming in from a CDC, it's just key value updates, right? So you can't do even 2 field operations because all the changes are coming as key value updates. You get what I'm saying?
Yeah.
So then you need to look into Kafka streams, which can materialize the updates into a K table inside Kafka streams. It kind of materializes a virtual table for you. And then you can do cross-field transformations and calculations and update the topic in place, right? And then Pulsar streams similarly. But in Kafka streams or Pulsar streams, you have the ability to go beyond that one message and outside of the ecosystem. I can ask Ryan, he made the SMT for what we were working on. I don't think SMT can do anything beyond the actual message. Like it can't go call something else. It's literally just in message transformation.
Okay, yeah, that answered my question pretty well.
Cool, great. Any other questions?
No questions from YouTube.
Okay, great. All right, well, looks like we're good to go. Thanks so much for hosting, Arpan, and we'll